So now that we've learned the remainder theorem, we can use it if we want to find a remainder when something is divided by a certain binomial, as in this case. Now, we could also find our remainder using the techniques that we learned on Friday. So we could use long division and find the remainder, or we could use synthetic division and find the remainder. Sometimes students say, you know what, when I find the remainder, I like the synthetic division. I think it's still the fastest way. Depending on the numbers that you have to use, sometimes the synthetic division will still be faster than using the remainder theorem. So we'll look at part A. We'll solve it with the remainder theorem, see what that looks like. We'll solve it with synthetic division, see what that looks like, and we'll discuss, in this situation, which one was better. So according to the remainder theorem, we can find the remainder. If we call this polynomial p of x, we can find the remainder by plugging in 3. So we would have 2 times 3 to the 4 minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3. Two times 81, 5 times 27, 5 times 9, plus 15, plus 3. 162 minus 135 minus 45 plus 18. Get 0. Okay. Some big numbers there. Some big mental math numbers that you would have to use if you use the remainder theorem in this case. What does this same thing look like in synthetic division? Well, synthetic division, you'd set up your box. You have 2, -5, 5, and 3. Just a quick check to make sure that none of our powers are missing. Starting at a power of 4, and we go 3, 2, 1, 0. Okay? A quick check, if you want, to see if you have the right amount. If your highest power is 4, you should have 5 numbers. If your highest power is 6, you should have 7 numbers. If your highest power is 1, you'll only have 2 numbers, but you won't have one that small. So that's a nice way to quickly check it. Now we can put a positive 3 on the outside. And let's compare the mental math we'd have to do here. Bring down the 2. 2 times 3 is 6. Add them. 1. Add them. -2. -6. -3. 0. So if we would go back in time things, I think the synthetic division in this case was quite a bit quicker. Okay? Also in synthetic division, the biggest number we had to worry about was 3 times 2. Which equals 6. So the adding and subtracting we had to do with synthetic division, I think made this one nicer. Also, if you use synthetic division, you've already got the division statement ready. So if you were trying to factor this, you've done one step towards factoring it, and you're that much quicker. Okay? Now, there will be certain situations that using the remainder theorem will be better than using synthetic division. And we'll see some of those situations. So it's nice to have both of those tools, but I find that as soon as your numbers, like if you're dividing by x minus 3 or x plus 2, as soon as those numbers are different than a 1, like if it was x minus 1 or x plus 1, then I might find, yes, the remainder theorem throwing in a 1 is super quick and super easy to find out what the answer would be. But if the numbers are bigger, you might want to go to synthetic division. So I want you to try B on your own with both the remainder theorem and synthetic division. And then after that, try 4a, 6a, 7 and 8.